Assalamualaikum and good afternoon. Can you all hear me?
Yes,
Yes.
Okay, can you see the screen?
Yes, sir.
Okay, that's good. Okay, I'm Dr. Anwar. But before that, do I need to speak English or I can speak Bahasa? Is there anybody from overseas?
Yes, doctor. I am foreign student.
Okay, you're foreign student. Okay, then I have to speak in English then. Okay, okay, for this course, the second half of the semester, we are going to deal with pile foundation, lateral earth pressure, retaining wall, and soil improvement or slope. Okay, for this course, they are going to be for my part, for the second part, they're going to be 2 assignments, 2 quizzes, and also 1 test, and also a computer project where we're gonna use Fluxys, which on Monday I give you assignment to try to find out what is Fluxys all about. And since you cannot go to our computer lab, then it's better for you to download it from the internet, or maybe you can get it from even Shopee selling it for I think 7 ringgit, something like that. That is for educational purpose and not for commercial purpose. Yeah, you can use that, but later maybe in the next 2 or 3 weeks, then I'm gonna give the assignment or project, computer project. Yeah, for those who want to have a record of this video, you can have, and we one of you do the recording, because my PC is too slow. I'm not sure whether I can record, because last time I try, it hangs on along the recording my computer just hang. I think cannot. My RAM is not so big. But you can try. Somebody can try to record it. Okay. So that is what we're gonna do for the rest of the semester. Okay, and for today, we're gonna look at the pile foundation. I already upload or send you the chapter 9, the pile foundation. Sometimes they call it the deep foundation, because I think in the past, in the first section of this semester, I think you learned already the shallow foundation. So piling is about the deep foundation. And Dr. Aizat also have a lecture note on this one. If you want it, it's quite comprehensive, but actually it's just collected, or just a summary of what the textbook, the content of the textbook. So I'm not sure whether I'm going to use this one. I'm going to use it, but I'm also going to use the textbook as a reference, main reference for the lecture. And my lecture is going to be not really go straight forward to the, to the detail, because everything is in the textbook, where you can always refer it, since we do have the PDF file. So what we can do, I just want to guide you so that you can understand the content as well as do the assignment without much problem. Okay. If you look at the textbook, chapter 9, about file foundation, here they are, later on maybe you read this textbook. So here, okay, let's say, sometimes I prefer to use direct the textbook for the figure. Then when you read it, you can understand better. If you miss my lecture, then you can refer the textbook. Okay, for file, okay, before this you learn about shallow foundation. But for file foundation, okay, let's say this is the file, maybe something like this. Okay, the idea of having a file foundation, if you look here, because the load of the structure is so big that the soil cannot sustain it. Maybe they have a weak soil layer on top, or maybe there is no, the soil is so weak that it cannot sustain the load of the structure on top of it by using just the shallow foundation. So when it happens, then definitely we gonna need to have a deep foundation or pile. Okay, the idea of having pile is actually it can be for many cases. For example, the pile is socket to the rock. For example, like figure A here. So it seems here the load, the structural load is transferred through the pile to the rock. So the rock will take the load. And yeah, that is a normal case. Normally we go until the rock level. But if the rock level is too deep, as if we cannot find the rock too deep, then we need to consider the skin friction. For example, for case B here. So, and definitely here there is a small area at the tip there, also support the load, but it's not so much. But the actual load, structural load, is taken care by the skin friction along the skin. The skin, the friction of the skin here is handling the structural load. Okay, that is for a second kind of pile foundation. And for the third one, it is to support the lateral, here the lateral or the horizontal forces. If there is a horizontal force, so we can take care of that lateral force by having a pile. This is also actually taken care also the vertical force. Let's say we have a vertical and horizontal force. So we can cater the horizontal force by having a pile, which will take the moment. Yeah, those are the three one. And sometimes the soil is a soiling soil, meaning when the soil is exposed to moisture content, then the soil will increase in volume. So it expand. It become the volume become larger and larger. We call it a problematic soil. What happen when the soil swelling, then it is more or less is like a pushing. It is push the soil upward, so it will be a uplift because the soil is moving upward, so it is also pushing the pile upward also. So in this case, normally we need to put the pile until below the swelling soil, so that to a stable soil like this one, so that it can cater, because this one it become it's not supporting. It is actually become negative instead of positive. So it become negative and there is a swelling soil. And this thing also happened to field area. For example, when you do the cut and the fill for soil, and when you fill, the area of fill is not suitable for pile unless you know how to handle it, because the field area is going to, it's not stable, so you need to really take care of it carefully. That is in practice. Normally some they trying to avoid having a pile foundation in the field area unless we have a good stable soil underneath. And for this part, the figure E, that is when we want to cater for the uplift. Let's say the pile is supposed to not to take the to sustain the structural load downward but upward. For example, application this is like where we have a advertisement board, where we know that there are going to be winds, and the winds is going to take the board away, and then it is like we need to have a pile foundation so that it can hold the board or the structure from moving away. So there is another function of pile foundation. And the last one, this one is when we have a zone of erosion, something like this one. So it's not suitable to have a shallow foundation because we have a zone of erosion, like in the abutment or something like that. So when we cannot have a shallow foundation because there gonna be a zone of erosion. Then we need to have pile, not because sometimes because of the strength of the soil, but because there is erosion in that area. So we need to consider pile foundation instead of shallow foundation. So these are the use, how we use pile in civil or geotechnical engineering application. Okay. There are many type of pile, for example, steel. And normally steel, the issue, you can look at the detail, because if I were to go into the detail, we may not have time. And sometimes it's not that important also, the detail, unless you really want to do the design work, then you may look at the detail. But now it's more important you understand the concept or the theory, the issue, instead of the detail of it. Okay, we can have a steel pile, but the issue with steel pile is normally the corrosion. When we apply or put it in what we call it, the soil that has moisture content, for example in peat or in clay, then we may have issue of corrosion. Or even if we put it in sometime for seawater, it's going to be corrosion also. So that is the issue with the steel pile. But the advantage, normally it is a high strength and not heavy to handle. We can easily cut off or extend and so on by using the steel pile. Normally we use the H type, H pile. All the figure here showing the cross section of the steel pile, and it can also be a circular pile also for steel. And normally at the end, we weld it and we close it. Sometimes we don't. Depend on your calculation. Besides that, we also have a concrete pile. Concrete pile, it can be a precast or pre-stressed and so on. So many types. The thing about concrete pile, we can have a hard driving. When we drive the pile, we can really hit the pile, because concrete can sustain compaction very well, and also resistant to corrosion. We can put it in clayey soil, but difficult for us to cut, to trim and so on, to extend, and also difficult to transport because it's heavy. And we can have several kind of section for concrete. You can see this one. Okay. Also, we can have a timber pile. But the issue with the timber pile, we can drive it too hard, because pile cannot sustain or withstand the hard driving stress. It's going to split. Some timber pile is used for soil that is soil with moisture content. Okay, and we can have also a composite pile. Composite means several material. We use several material for a single pile. Maybe we concrete plus plus timber and so on. Okay, we also have the CFA pile. Okay. Okay, the idea is those are general information. Most important for us in construction, we need to estimate what is the pile length, the length of the pile that we need, so that we have enough bearing capacity or enough load or ultimate load that can sustain the structural load. So to estimate pile length, we need to know the point bearing pile. Point bearing pile is the part. Okay, to get the ultimate pile load. Okay, this is the equation. Ultimate, the load for ultimate that the pile can sustain is the load at the point, at the base. Okay, like this one. So the base here is the point, and this one is the skin. Okay, so ultimate load that the pile can sustain equal to the load that the point at the point and also at the skin area. So if we combine those two load, then we get the ultimate load. Okay, here we have three cases. A is clear, the point load. The load Q ultimate is about Q at point, because it is sitting on the rock. So the rock at the end of the pile or the point there. So there is the load that ultimate for the pile. And for case B, sometime when we don't have the rock and we have a weak soil, so we need to depend on the skin friction, skin friction of the file. And then normally skin friction is not good enough. It's not big enough or heavy enough or large enough to handle the structural load. So the load of the pile, the ultimate load of the pile, depend, since there is no rock, then need to depend on the skin friction also. But for the case B there, so we need also to have a strong soil layer. Instead of rock, we also depend on the strong soil layer to cater for the load. So in this case, QU or ultimate load equal to QS skin friction plus QP load at the point. So this case is QU equal to QP plus QS. This one is QU equal to QP. In this case, we can assume skin friction is not giving large enough. It's little contribution. And for part C here, since there is no strong soil layer and there is no rock, So we need to depend on the skin friction only, because the QP here, because the area at the tip here is not large. The area is not large, so we can say QP contribute very little that we need just to consider only the QS, the skin frictions only, because this one is so small. Okay, that is the case, 3 cases. And here they're talking about the friction pile, where no layer of rock. Compaction pile, sometimes in sand, we need to compact, do a compaction pile. We need to compact the pile in such a way it can also compact the soil. That we call it compaction pile. Okay. To install the pile, there's so many methods. It can be hammer or vibratory driver. So one is just, then the hammer. Vibrate is, it is not using the load. It is about vibrations. For example, like this one is the hammer. So where we have a ram here and we have a cushion, so that the pile cap is not going to split. So we just hammer on the top of the pile caps. Okay, these are methods of installing the pile. Yeah, there are a few methods here you can read. And I think one of the latest one, this is I think still the pile driving hammer. Now they have in market, they have, let's say this is a pile. They have they call it pile jacking. So you just push the pile instead of hammer. You just push the pile. Hydraulic jacking. So, and it's not vibrating also, it's just pushing. So it is good when we want to install pile near the sensitive structure, existing sensitive structure. For example, near the buildings and so on, or near the tunnel and so on. So we need to use that. Yeah, I think yeah. Okay, those are about how to install the pile. Okay, and this is a concept for pile driving. But you can read on your own. It's not difficult, because if you were to go through all these, because for pile foundation, in practice, the consultant normally they adopt the method or that is that they are comfortable with, because there are hundreds of methods. In this textbook, sometimes they don't use. They have their own way of calculating the pile capacity, pile length, and so on. So even if we look in this textbook, there are many methods. Okay. For your for the purpose of understanding, not for practical. For practical, maybe you are not going to use this one. maybe use a different method. But for the sake of study, we learn the conventional or the established method. For example, here we have like Terzaghi, using the Terzaghi equation. This is like the shallow also. We use the same concept. Okay, the idea, if you get this idea, ultimate load of a pile equal to the load at the point or the end of the pile plus the load we obtain from the skin friction, the circumference of the pile. So these equations is very important. So using, for example, for the point bearing capacity, QP here, we can use the Terzaghi equation also. If you still remember, for shallow foundation, we use for square foundation. We are talking now at the tip only, not the skin here. The tip only. Excuse me. Okay, for the tip only, QP. For square foundation, we can use the exact equation for shallow foundation. And for circular also, we can use the same Terzaghi. Okay. And if you still remember, in shallow foundation, there is a general bearing capacity equation. Yeah, which look like this one. Bearing capacity, ultimate bearing capacity equal to this equation, where you need to get the shape factor and so on. So many factor here, if you still remember. So we are going to use a lot of table to get the n factor. Okay, for example, the depth factor and so on. Okay, so the concept is still the same if you're using the Terzaghi on all general bearing equation. And we can say the QP equal to this equation, where area at the tip of the pile time QP, unit point resistance, equal to this equation, which you know already, what is NC, NQ. Okay, those equation are for QP. For QS, or the skin resistance, the equation is like this one. Here, summation of P. P is the parameter of the pulse section. And then delta L is the length, but the incremental one, because we consider, okay, not the whole section. We consider section by section. So we have the incremental length, because the skin friction, they are not the same along the line. So it can be different. So we need to consider maybe 1 meter apart, or 1 meter, 1 meter, 1 meter. It can be one layer of soil. Different layer has different property. So it depends. So to get the QS, we need to also multiply with F here, which is unit friction resistance at any depth. So along the depth, the F value could be different. Okay. That is how to get the Q, P, and QS. To get the Q allowable, we know that this equation is true for many cases. Whatever allowable is actually ultimate over factor of safety. In this case, it's the load, allowable load for the pile, meaning that for this pile, the load allowable to it is actually what is the actual strength, the highest strength divided by the factor of safety, then that is what is allowable. Let's say the strength is ultimate 100 kilonewton. Allowable if factors of safety is 2, meaning that it is only half. If 100 kilonewton, we allow only 50 kilonewton for the loads to be applied on the pile, meaning that the structural load should be only 50 only, no greater than that if factor of safety equal to 2. So as you know, factor of safety normally from 2 to 4, meaning that if the pile can take 100 kilonewton, in practice we apply force to it or the structural load less than 50, maybe I don't know 2.5, 100 divided 2.5 or 4. Let's say factor of safety is 4, meaning that the pile can take 100 kilonewton, but we allow people to have a structural load only 25. The factor of safety is 4. So is this supposed to be very safe? If, I don't know, if we as engineer design something and let's say failure happens, I don't know, we are talking about factor of safety 4. The pile can take 100, but we allow only 25 kilonewton. So we are in the safe side, but if failure still happen, I don't know, then we need to we already safe actually, okay. And yeah, this equation is showing the calculation for QP, and it is supposed to be less than this value, area of the point there, time QL, limiting Q. Okay. So you can limiting point resistance, the equation is given here. But you will come across actually all these when you want to solve a problem. Sometimes if we just give the theory, go through the procedure, how to calculate and so on, but if we don't really practice on the real problem or practice, then it just comes from your left ear and then it goes to your right ear. So it is always good to practice, have a problem, trying to solve it, and start looking at the procedure or even read which part from the textbook is related to it. And that is a more practical, instead of you read all this and then at the end we lost. When we want to do the assignment or do the problem, we have to read it again to understand. So it become, we come and back to the note so many times. Okay, but that's okay. I just want to go quickly, and then maybe later on we will do some practice. Okay. Okay, this is different method. Previously, we are talking about general equations and also the Terzaghi equation, how to get the QP and QS. But this one is how to get the QP using basics method, different method. So there are many methods. So and this textbook also so lengthy, see, it try to give as many method as possible, but actually in the practice a lot more, 100 more. So depend which method is for you more comfortable. Okay, using basic for sand. Okay, to give you some general idea. Okay, let's say this is a pile. This is a pile. When we want to install or design the pile or pile foundation, we need to consider whether this one is supposed to be steel or concrete. The soil, is it clay or sandy soil? And then we need also to consider whether there is a weak soil or whether there is a rock, so that we can socket the pile. We need also to consider whether the soil is expansive or swelling or not. So many things to need to consider before we can just use the equation given here. Here we have so many methods and definitely so many equations. Even up to here is already 19 equation. Okay, so for sand, okay, then we need to think about sand now. So we can use this equation QP for sand, and you can look at this one. I mean, this is important when you want to do the calculation, but for theory, yeah, we just look at it and understand what it is. For example, like this equation, AP, we know what is the area of at point, area at the point, cross section. Stress is the at the stress of the ground stress. Effective ground stress at the point of pile point. At the pile point there, at the end of the pile, what is the effective stress there? And then K is the K naught. Okay, where is it, the K? Or this equation. And then the NQ is given here. So you can use this equation for basics, and you'll be introduced with some other, because here they introduce new parameter, so you just need to follow it, what it means. Okay. Here normally for bearing capacity factor, similar like previous in the shallow foundation, normally is given if we know the phi value or angle of internal friction, normally is given, then we can use the table or equation to get the N value factor, bearing capacity factor. Okay, and for clay soil, where for clay we assume phi equal to 0. So for clay, we assume P equal to 0, or phi equal to 0, or internal of angle friction equal to 0. That is for clay. So we can get this equation for NC. And if you go through, it is a straightforward. It is just a matter of, if you get the they are given a certain parameter. From that parameter, you calculate other parameter, and then you plug into the main equation, and that's it. It look complicated, but it is like procedural. To calculate it is a procedural, meaning that you have to go step by step. Okay, and then there is another method called an Castello method to get to estimate QP in sand. I think you can go through this one too, and so on. Okay, here there is one example which you can use as a guide to calculate the QP for different methods. Okay. Yeah. So you can look at this one and try to understand it. It's a straightforward. You cannot understand, go back to the lecture note. Okay. Now we spend about 50 minutes. But I don't want to spend the whole time just talking because without having some output from you also. So why don't you for this okay, you can go through all this one. I'm gonna give you, since we have another about 1 hour, so why don't you go for today? I would say that is a quiz. For the quiz here, okay, try solve problem 9.1. Okay. 9.1 until 9.3. You and I give you, I don't know. Yeah, this 1 hour. Maybe I give you 2 hours. Is it okay? 2 hours for you to do this one? Actually, it's just you look at the example there, and then maybe sometimes you need to read the text also for you to get the hang of it, and then try to solve this. Okay, one and okay, no, just okay, 9.1 only. As a quiz, quiz number 1, in 1 hour, I think you should be able to finish it. Just 9.1. Is it okay?
Okay, Doctor.
Okay, 9.1, that is a quiz. And I'm going to go to open a quiz in your UKM folio. You can submit it there. Okay. Okay, so you can start working on problem 9.1, and you have 1 hour to read that part until Mayer-Hall method, Versick method, Qual and Castello method. Just to get here QP. Okay. Then submit it in UKM Folio. I'm going to create the quiz there. Is it okay? So you have until 5 until 6. Okay, nah. So I'm going to leave you, and I'm waiting for your for you to upload the quiz there. Maybe I can. Hello, any question before I leave?
No question there.
No question, okay.
Like,
So, okay. So this is 9.1 only, yeah? Okay. Okay, I'm going to work on creating the quiz in the UKM Folio, so that you can submit. Okay, then see you next week then. Okay, see you next week then.
Okay, Doctor.
Okay. Okay.
Thank you, Doctor.
Yeah,
Thank
you
you.
can also leave, no problem to leave. So for today, the lecture up to here. So it is just your part to do the quiz and submit it before 6. Okay.
Thank you, Doctor.
Doctor?
Yeah.